Everything that we are going to discuss in this course can in some way boil down to what's the flowchart that's contained on this slide. So we have four components here. We have the data, which I'm calling block 1. We have a model for the data, which I'm calling block 2. We then have some sort of an inference algorithm, block 3, and we have a task or some goal that we want to do, like predicting or exploring the data, which I'll call block 4. And they all fall into, all the algorithms or techniques, the motivations, have this same sort of a flow. So we have a data set, we start with that. We have a goal, what we want to do with this data set. We have this here. We then have to define some sort of a model that's going to get us to our goal. This part here. We have to define a model for the data that's going to do for us what we want it to do, like make predictions or find the structure in the data. But this model is going to have unknown parameters to it. And we need to learn these parameters. And so that's where block 3, the inference portion, comes into play. So we basically say, here's a model with some unknown parameters. Here's a data set that we're going to say that we want to model with this model. Now tell me what are the parameters I should set the model to in order to model it well. That's block 3. And when we learn those parameters, we can then take new data and make predictions or explore the data set. So if you remember from an earlier slide, we discussed the two different perspectives or different pairs of perspectives that we could take. And they all kind of fall into these different ways that we can view these blocks. So for example, the difference between supervised versus unsupervised learning can be thought of as comparing as block 1 and block 4, thinking of block 1 and block 4. So what is the data and what do we want to do? If we have data where we want to predict an input, predict the output for an input by learning some function that maps inputs to outputs, then we're doing supervised learning. So that's what block 1 and block 4 will tell us to do. If we want to simply learn the structure underlying our data set with some sort of a model, for example, we have documents and we want to learn the topics, those documents, to explore the data set, we might want to do an unsupervised learning model. And so unsupervised versus supervised can be thought of as what block 1 and block 4 is telling us, and then block 2 and block 3 are the set of techniques that we perform toward that end. If we think probabilistic versus non-probabilistic models, we're now not really thinking about the data or what we want to do with the data. We're thinking about the model itself primarily. So we're defining a model that uses probability distributions in the probabilistic case, or we're defining a model where probability distributions really don't come into play at all in the non-probabilistic case. And also, to a certain extent, the probabilistic versus non-probabilistic dichotomy appears in block 3 as well, in that some algorithmic techniques are purely motivated by the fact that we're doing a probabilistic model. However, a lot of techniques for non-probabilistic models apply equally as well to probabilistic models with no modifications at all. So to some extent, block 3 is shared across the two, and the difference between probabilistic versus non-probabilistic modeling is primarily in the types of models that we're going to define. Also, there was the difference between focusing on defining models versus focusing on defining the optimization techniques for learning models or for maximizing or minimizing objective functions. And so this one is very clear-cut. If we wanted to focus on model development, we would be focusing on block 2. If we wanted to focus on the different optimization techniques, regardless of what model that we're thinking of, we would focus on block 3. So these are just ways of thinking about the problems. Again, every algorithm, every model, every lecture that we work through in this course is going to in some way be able to be boiled down to the information on this figure.